A rock from the void, silent, fast, and invisible, could rewrite human history in a single flash. On May 15, 2025, in a solemn chamber within the US Capitol, the House Committee on Space, Science and Technology gathered with NASA's top scientists and experts. They weren't celebrating a triumph, unveiling a new launch, or awarding medals. Instead, they sat face to face to confront a profound, unsettling reality. If a civilization-ending asteroid were on its way to Earth, would we be ready to stop it? It wasn't a theoretical exercise. The question had a real-world spark. Asteroid 2024 YR4. Days before the hearing, its discovery stirred alarm around the world. Early models showed it had a small but notable chance of impact. As observatories scrambled to collect more data, public anxiety simmered. Ultimately, recalculations showed it posed no danger. But the episode laid bare how easily the thin line between safety and disaster can fray. And so, attention turned to the mission designed to find these threats before it's too late, the Near-Earth Object Surveyor, or NEO Surveyor. This infrared space telescope is NASA's most advanced planetary defense project yet. It represents not just a tool, but a turning point in how humanity watches the skies. But while NEO Surveyor looks up, political crosswinds are closing in from below. The Trump administration's latest skinny budget proposal recommends a 24% cut to NASA's top-line budget and a 47% cut to science programs, including planetary defense. It would be the largest single-year reduction in NASA's history. Representative Valerie Foushee, D. North Carolina, was blunt. If enacted, this budget risks putting NASA on a path to irrelevance. It threatens our economic and national security, surrenders US leadership in space to adversaries, and jeopardizes our global standing. So, what are we at risk of losing? The telescope meant to protect Earth, NEO Surveyor, isn't just a telescope. It's a planetary guardian. Scheduled to launch in 2028, it will scan the solar system for asteroids and comets that could collide with Earth. Unlike traditional telescopes that rely on reflected sunlight, NEO Surveyor uses infrared vision to detect heat signatures. This allows it to spot objects that appear dark or invisible in optical wavelengths. These stealthy asteroids may not shine, but they can still strike, and with deadly force. The significance of this detection method was driven home by the Chelyabinsk event in 2013. A 20-meter asteroid exploded in the atmosphere over Russia with 440 kilotons of energy, injuring more than 1,000 people and damaging thousands of buildings. It came from the direction of the sun and thus remained completely undetected by ground-based observatories. Chairman Brian Babin, R. Texas, recalled the incident at the hearing. That asteroid was small by planetary standards, and still it caused widespread injuries. Imagine a larger one, and imagine we don't see it coming. NEO Surveyor changes that. Dr. Nicola Fox, head of NASA's Science Mission Directorate, described the telescope as a cornerstone of planetary defense. We don't currently know of any object on a collision course within the next 100 years, but we also know that our census of potentially hazardous asteroids is incomplete. Finding them before they find us is our top priority. Fox also emphasized that NEO Surveyor will be able to measure asteroid sizes more precisely. Knowing size isn't just academic. It determines impact energy, crater size, and potential devastation. From seeing to saving, DART and beyond, detecting a threat is only the first step. Acting on that knowledge is the next. In 2022, NASA made history with its Double Asteroid Redirection Test, or DART. It launched a spacecraft to deliberately crash into Dimorphos, a moonlet orbiting the asteroid Didymos. This wasn't a Hollywood stunt. It was a real test of whether we could push a space rock off its path. And it worked. The impact shortened Dimorphos's orbit, confirming that kinetic deflection is possible. DART proved that planetary defense is achievable, but it depends entirely on advance notice. Dr. Amy Mainzer, NEO Surveyor's principal investigator and a professor at UCLA, put it plainly. We can't deflect what we don't detect. NEO Surveyor gives us the early warning we need to launch missions like DART when it truly matters. Mainzer also noted the critical importance of calculating asteroid sizes. Impact energy depends on diameter. With infrared, we can get that measurement quickly and accurately once we determine the orbit. That helps emergency managers plan responses based on realistic scenarios. Cuts that could blind the planet. Despite its promise, NEO Surveyor may never launch if funding evaporates. Lawmakers and scientists fear that the proposed budget cuts could trigger a cascade of consequences, from shelving critical missions to shuttering entire research centers. Documents suggest that even NASA's Goddard Space Flight Center in Maryland could be on the chopping block. The Ames Research Center in Silicon Valley, another key player in planetary defense, is also vulnerable. Dr. Fox was asked what would happen if Ames were forced to close. Her answer was stark. We would lose our ability to deliver timely scientific assessments to FEMA. That includes advising where to evacuate and how to save lives. That capability would vanish. The stakes go beyond infrastructure. They touch human capital. Dr. Mainzer emphasized how expensive and time-intensive it is to train scientists capable of leading missions like NEO Surveyor. We can't afford to hemorrhage expertise. It takes years, sometimes decades, to build the skills needed for deep space detection and trajectory modeling. Matthew Payne, director of the Minor Planet Center, echoed the urgency. We monitor the orbits of over 38,000 near-Earth objects. Of those, at least 2,500 are potentially hazardous. That's not theoretical, that's a rolling list of threats, and the list grows every month. AI, global cooperation, and the next frontier. There was some optimism during the hearing, especially around emerging technologies like artificial intelligence. When Repl Fushi asked whether AI could enhance asteroid detection and impact modeling, both Payne and Mainzer agreed. AI could help sift through the enormous volumes of data collected by telescopes and sensors. It could also improve orbital prediction, automate alert systems, and dramatically reduce false alarms. But again, funding is the gatekeeper. Dr. Fox responded, AI holds promise, but integrating it into a robust national planetary defense framework requires investment. We can't innovate on scraps. She also raised a haunting question. If we can't come together to protect ourselves from a rock that could end civilization, what else will it take? The only preventable natural disaster. Perhaps the most powerful moment of the hearing came when Rep. George Whitesides, D. California, a former NASA executive, spoke. We can't stop earthquakes, we can't stop hurricanes, but we can stop asteroid impacts. This is the only natural disaster that is 100% preventable. So why are we cutting the program that could save us all? Planetary defense is not a side project. It's not science fiction. It's a planetary necessity. We now have the tools. We have the missions. We have the vision. All we need is the will. So here's the question for all of us. Will we invest in our survival, or wait until a city disappears before we take space threats seriously? Let me know in the comments, and subscribe if you want real stories about science, survival, and the people working to protect us all. Because one day the sky could fall, and if we're ready, it won't.